Hey class, we are going to be learning how to simplify expressions. So, starting from problem 1, 16 and 5 over 4. How would you simplify that? Amelia, do you know how to simplify that?
Yes.
What is the first step?
To put wait no.
No. I will explain how to do it. We look at the solution, right? We look at the problem we need to plug in. Our x is 16, our m is 5, our n is 4. The formula is supposed to look like this. And so you plug in those numbers as you see them. The 5 would go on the inside with the x. So we plug that in. 5 would go on the inside of the square root with the 16. And as we see, the n is on the outside. So we take that 4 right here and we put it on the outside. So we get this answer. Do you understand?
Yes.
Good job.
So we use Desmos to graph this formula, and this is how our graph looks like. We plugged it in and it gave us this table. More details coming soon.
I'm Arthur and I'm going to talk about this graph. So these are the inputs, which is x. And with these inputs, we put it into this. And when we put it into Desmos, it gave us the outputs. And when we put all this into this, we get our numbers. And Desmos gave us an infinity line, you know? It goes on forever.
Hi, this is Kristina speaking, and the domain is the horizontal and range is the vertical.
And going on off of that, you guys may be wondering, what is the domain and what is the range? Well, we know that if you have an endpoint, that's where it's going to end. But here, we obviously don't have any endpoints. They go on forever, which is why it's infinity. So looking at our domain, it goes from infinity forever on this side, all the way to infinity on this side. So that's why we have negative infinity, because over here, these are all negatives, and we have positive infinity over here, which is why it's positive. And then going on the range, which is our vertical, we see that vertically, they are both going up forever. And again, that is why it goes negative infinity and positive infinity. But yeah, that is how you find out your domain and range.
Signing out from
Signing
Math
out.
News.
Yeah. Окей. Привет всем. Это русская версия, как нам найти домен и диапазон этой проблемы. Впервые мы начинаем с этим графиком, и мы смотрим на номера. Мы юзали веб-сайт Desmos, и мы поставили номера в этот график, и он нам дал таблицу, и у нас получился ответ вот такой. Это у нас эксики, это наши y's, и эксики мы ставим вот сюда, а y мы ставим вот сюда. И с этим веб-сайтом он нам дал линию, которая идет на бесконечность. И она показывает нам наш домен и да, и диапазон. И мы смотрим, что для домена мы смотрим на эксик, и он, конечно, идет на бесконечность. Но вот тут мы видим, что это все негативные номера. И вот почему мы ставим сюда такой номер. Негатив, бесконечность. И потом мы смотрим сюда, это все позитивные номера. И вот тут будут позитивные бесконечность. И то же самое с диапазоном. Мы смотрим, как оно идет, потому что диапазон идет, как сказать, вверх до низа, и оно на бесконечности идет наверх, потому что мы не видим, тут нету конца, здесь и здесь. И вот почему она идет опять негативные номера, и она идет негатив бесконечность и позитивная бесконечность. И это как мы находим наш домен и диапазон.
До свидания.
This is Math News, and we are going to be talking about how to find domain and range of an expression. So going on to reporter Amelia. Okay, for the next problem, we have this. Arthur, why are you not paying attention? Do you know how to do this?
No.
No? Well, let me lay out the steps for you. Obviously, we rewrite our solution or our problem, and we know that with an exponent, we have to distribute it, right? So we have to distribute 1/2 to 5 and 1/2 to 4. How would you get our answer? What's 5 and 1/2? 5 times 1/2. It is 2.5.
Oh, I see.
Because,
Yeah, that makes sense.
yeah, we multiply it, and then with y and 4, we have to distribute it, and we get 2. Does anyone have any questions?
Mrs. P,
Yeah.
how come it's 2? Wouldn't it be a larger number?
The thing is, when we see fraction form and we have a 1 on the top, in a way we just ignore the 1 on the top and we just divide. So 4 divided by 2 is 2. Same thing with 5. 5 divided by 2 is 2.5.
Okay, that makes sense.
Yeah. Okay. All right. And to continue, Arthur, we obviously get our new answer right here. But what do you see that's wrong over here? What do you see that's off? Because we got 2.5, but it can't stay like that. It has to be in a fraction
yeah.
form. Exactly. What do we do with that fraction form? We have to do something with it. It can't stay the same.
Can you get like a whole number?
No, but you have to use a formula that we use right over here. But we use it over here. So we have x and 5 over 2. We bring it over here and we see that the top number you plug in inside, the n you plug in outside. And so we take our x is right inside the square root, and then the m is 5, so we take that 5 and we plug it in inside. The 2, which is n is on the bottom, the denominator, and so it's on the outside, and we plug in our y and we get a new equation. And that's how we simplify it.
Okay, yeah, that makes sense.
Okay, so going on to our last equation. To start us off, we know that the exponent next to the parentheses is the equation we're going to start off with first. What do we know about zeros?
0 distributed to any is equal to 1.
Exactly. So if we distribute 0 to y and distribute to x and to the exponent of -3, we get 1 because, as you said, 0 distributed is 1. So we move on to our second parentheses. And what do we do, or what do we see that's wrong with at the exponent? What's wrong with the exponents? Or one of the exponents? Arthur, do you know?
It's a negative?
Yes, it's a negative. So, one of our formulas show that it is turned into an equation like this. So, we get the x, which is our y, and our number as the exponent, and we turn it into fraction form. So, it turns with 1 on top, y and -1 as the exponent, and then we take this answer and we plug it in and we get our answer.
Wait, what about the 1?
The 1, well, we know that 1 times anything stays the same. So the number doesn't change. And we already know that 1 times this, which is equal to this.
Uh-huh.
Okay, that's how we get our answer.